Hello, my name is Jim Rosson. I'm a research forester for the Forest Inventory and Analysis Work Unit located in Knoxville, Tennessee. I'm going to talk today a little bit about vulnerable and rare species in the forest inventory. I've spent my Forest Service career in forest inventory, first in the field collecting data, then moving into the office to process that data, and finally moving into a research forester position. I'm going to take advantage of this virtual presentation format to pack a lot of information in slides that people can come back to at their leisure and look at later. A little bit about the introduction to this presentation is that vulnerable species are usually the rarer species across the landscape, and decreases in vulnerable and rare species populations may be an indication of ecosystem decline. I put some information about why rare species are important and why study rarity. Continuing with background, a basic tenet of biology is that rare plant species may be highly vulnerable to disturbance events, either man-caused or natural, such as weather. These disturbances may cause dramatic declines in population numbers or worse, even lead to extinction. So conservation and policymakers need inventory and monitoring information about plants to manage existing resources. They need to know what the rare plant is, where is it, and what is the current status. In this presentation, I want to use Arkansas Forest Survey data as a case study and hopefully demonstrate how this survey information may be used to point out rare and vulnerable species across the landscape. A good place to jump into the subject matter of rareness is a book by Gaston in 1994 titled Rarity. It has an excellent reference, and you can see the complex array of problems that comes in defining rarity. In this study, I define rarity as those tree species of low frequency in the sample. However, attention needs to be made both to the natural history and the biology of the particular species in defining rareness. So what are some of the consequences of disturbance? This is a graphic by Reid Noss, and it shows what happens to natural stands after they undergo repeated disturbance. You can see that the stands become younger, simpler, smaller patches, isolated patches, less fire, more roads, and to the subject matter at hand, more endangered species, and this usually impacts the rarer species. As I mentioned before, I'm going to take advantage of this virtual presentation format and pack a little extra information into the presentation. I'm going to kind of rapidly go through the sample design section. Some people know about FIA and are quite familiar with it. Other people aren't, so I'm going to go ahead and include that. Again, the study plot population came from Arkansas. I used FIA data, and the plots were collected in 2011 to 2015. Important in this is to remember is that the sample design in FIA is a repeated measures design, and that's the same plots with the same methods are measured over time. And basically in the United States, in the East on a 5-year remeasurement period, and on the West 10 years. This slide shows the FIA hex grid laid across the landscape. This slide illustrates the size of the FIA footprint. The FIA sample unit consists of 4 subplots, and the red triangle denotes that's about 1/4 of a hectare in size. This slide gives a little more detail about the sample unit and the subplots that make up that sample unit. This slide illustrates a single hex unit overlaid on an aerial photograph with one FIA sample unit located on it. This is a map of Arkansas that shows all the forested FIA plot locations. There's 3,566 of them that have forest. A little more of the descriptive statistics. 109 tree species were in the tally, and the total tally was made up about 94,000 live trees. This slide illustrates the concept of oligarchy and how it relates to the study of rare species. And basically, oligarchy in a timber inventory, very characteristic of a timber inventory. Most of the importance value, and that can be basal area, it can be volume, saw timber volume, is held in a very few species. In this case, it looks like about 4 or 5 species are the oligarchs in the survey. The species to the right are the rare and potentially most vulnerable species in the survey. There are 2 ways to look at the data when we're going to analyze rarity. One is the pure frequency method, the frequency of each individual species in the total tally. The other is the occurrence on plots by species rank. And here you can see on the y-axis the frequency of the species in Arkansas. 109 species, remember, was in the tally. And you can see a J-shaped curve here, reverse J-shaped curve. This is a little more detailed look of the species rank distribution. I took the number 1 oligarch out, which was loblolly pine, which accounted for about 35% of the importance value in the state of Arkansas. And you can see that the J-shaped curve is much more predominant, and you can get a little more feel of what some of these rare species. Remember, there was 109 of them, and they become so rare that they disappear down into the x-axis. Finally, this look gives a better detail of that right side of the curve. Species number 1 through 60 have been left out of this data set. And as you see over here on the frequency, instead of in the thousands, number 61 species is at about 75 trees tallied out of the 900 or 94,000 or so trees. And you can see over here on the right, you can see a little more detail of the species on the very extreme right end of the curve. You can actually see them instead of them disappearing into the line, the x-axis line. So let's take a look at how the inventory data might be used, an application might be used. I picked out a tree here, cedar elm. It's species number 64 in the species rank. You can see it right there. Over here to the right is the trend for 3 survey measurements. I looked at the years 2005, 2010, 2015. And the frequency in those years, it started out at 66 cedar elms tallied in the state survey. Then it went to 70 and then back to 68 again. So basically we can say there's probably no change in the cedar elm situation in Arkansas. Carefully monitoring these changes over time can be done by looking at changes in rank and the magnitude of change in the frequency. This slide shows the species rank by the number of plots where they occur. And this gives some kind of idea about maybe a spatial distribution. And as you can see, using the same species rank, the smoothness of the going from left to right on the reverse J-shaped curve has changed a little bit. So we look here, loblolly, which was the number 1 tree that was tallied, it does not occur on the most plots in the state. and that belongs to the number 3 species white oak and number 4 post oak for Arkansas. And again, over here to the right, you can see the species on the right end of the curve, x-axis, disappear into the line. So again, I picked out a species to look at that might be suspect. And as I look across this line, I looked at species number 38, which is water tupelo, which is really low on the line and really out of sync on the number of plots that it occurs on. So I pulled up data from 2005, 2010, and 2015 over here. And what I found was in 2005, water tupelo occurred on 49 FIA plots. That dropped to 41 plots in 2010 and to 35 plots in 2015 currently. That's what this shows right here. So that might be an instance where a little further inquiry might be necessary to see what is really going on and what happened to those plots that water tupelo occurred on. For the sake of time, I'm going to let the audience come back and look at the takeaways at their leisure. There's quite a bit of information packed in this slide. I would like to point out just a couple of things and obstacles. One, defining rare species is a complex issue. The second thing, very, very rare species will not even show up in a large-scale survey such as FIAs. Therefore, be conscious of sample design limitations. And down here, the best way to monitor vulnerable species is through changes over time with a repeated measure survey, such as FIAs. And the repeated measures, inventory, and monitoring of the status of species populations is an important first step in risk management assessment. I want to thank everyone for listening today, and I hope everybody learned something. Thank you very much.